You know, right now, deep inside your body, there's a silent war being fought. And today, we're going to dive into the absolutely incredible story of a pretty humble immune cell, a specialized soldier with a really surprising job, fighting off some of the world's most common invaders, parasitic worms.
And we're not talking about some rare niche problem here. The World Health Organization estimates that intestinal parasites infect billions of people. It's a massive global health issue. So yeah, understanding how our bodies fight back is pretty crucial.
All right, so to get a handle on this battle, you first have to know the players. See, our immune system isn't a one-trick pony. It doesn't use a one-size-fits-all strategy. It actually has two totally different playbooks for two totally different kinds of enemies.
So on one side, you've got the Th1 response. Think of these guys as the special forces, right? They're experts at taking out tiny single-celled invaders like malaria. But when the enemy is a big multicellular worm, the body deploys a whole different army, the Th2 response. And that's what we're going to focus on.
Now, every army has its specialized soldiers, and in the war against worms, the absolute star of the show is a cell you've probably never even heard of, the eosinophil. And you can pretty much think of it as the body's grenadier.
So what exactly is an eosinophil? Well, it's a type of white blood cell, but its superpower is right there in the definition, these granules. They're basically little grenades, packed with super potent proteins designed specifically to mess up and kill large parasites, things that are way too big for other immune cells to just swallow whole.
But of course, these grenadiers don't just run around acting on their own. They need orders, and that's where the T2 cells come in. These are the brains of the operation, the intelligence division. They're the ones who spot the specific type of worm that's invaded, sound the alarm, and kick off the whole defensive strategy.
So how do they send out those orders? They use a chemical message, a little signaling molecule called interleukin-5, or IL-5 for short. And you can think of IL-5 as the official deployment order. When Th2 cells release IL-5, it is a direct command to your bone marrow saying, hey, we need more eosinophils. Build them and get them to the front lines. Stat.
So here's the chain of command, nice and simple. The worms invade, the Th2 intelligence cells spot them. They release that IL-5 deployment order, and boom, the eosinophil soldiers get mobilized for battle. Simple, right? Well, the first time this happens, there's a bit of a problem.
So let's zoom in and see what's actually happening on the ground. When your body faces a brand new kind of worm for the very first time, its response is powerful, sure, but it's also kind of slow, a little bit clumsy actually. The timing is all wrong.
And here's why that timing is so tricky. A lot of these parasitic worms have this really complex life cycle. After they get into your body, the larvae don't just, set up camp in your intestines. Nope, they take a tour, and a really critical stop on that tour is your lungs. And this whole journey is key to our story.
Okay, this diagram might look a little complicated, but it shows the problem perfectly. Just focus with me on the top part, the primary infection. The alarm gets raised in the lungs, where the larvae are causing all this damage. But by the time our eosinophil army finally arrives on the scene, the enemy has already packed up and left, continuing its journey down to the intestines.
So the result is, our soldiers show up to a completely empty battlefield. The defense was just too little too late. The worms get away and successfully set up a full-blown infection in the gut. The first battle is lost, but the immune system learns. And this is where it gets really good, because now the body has what we call immunological memory. So what happens when the exact same type of worm tries to invade a second time? Oh, the game has completely changed. Now this slide right here shows the ambush. In that bottom left section, you see the body now has these memory Th2 cells on patrol. They recognize the enemy instantly and unleash this massive, immediate flood of IL-5. Eosinophils are deployed with incredible speed, trapping and killing the larva right where they try to get in the skin and the lungs, before they even get a chance to establish themselves.
As the researchers put it, the skin itself becomes a critical fortress. This learned rapid response defense is just incredibly effective. The body has learned its lesson and it wins the rematch, no problem. But believe it or not, the immune system has one more incredible trick up its sleeve.
Okay, so we've seen the slow primary response, and we've seen the fast, specific secondary response. But this is where the research reveals something that almost seems to break the rules, a truly unexpected superpower.
So remember, the memory we just talked about is specific to one particular enemy. So by all the conventional rules of immunology, if a completely different species of worm attacks, the body should be right back at square one, right? Back to that slow, ineffective first response. But that's not what happens.
To understand why, we need to meet one more molecule, interleukin-33, or IL-33. The best way to think of this is as the body's general alarm bell. It's not released because of a specific bad guy, it's released by your own cells, like the ones in your lungs when they get physically damaged. Any migrating larva, doesn't matter what species, is going to tear through tissue and trip this alarm wire.
And this is the part of the diagram that shows the big twist. Look at the bottom right. That first infection, it left the immune cells in the lungs on high alert, kind of experienced. So when a new and totally different worm invades and causes damage, that general IL-33 alarm is enough to trigger these veteran cells. They don't recognize the new worm specifically, but they hear the alarm, and they respond by pumping out IL-5 and deploying eosinophils just as fast as a true memory response.
I mean, just let that sink in for a second. This is a form of non-specific immunity. Your body literally learns a general lesson from fighting one invader that it can then apply to a totally different one. It's like the first battle trained your soldiers not just to recognize one enemy's uniform, but to respond to the sound of any battle anywhere.
So, we've painted this picture of the eosinophil as this amazing hero, right? A powerful protector that learns to ambush its enemies. But the story has one last, complex layer. This cell isn't always on our side.
The eosinophil really has two faces. It's absolutely a protector, a first responder that kills larvae. But some really clever parasites, like Trichinella spiralis, have figured out how to exploit the eosinophil's other job, which is to regulate the immune system. They can actually trick it into suppressing the local defenses, basically turning our own soldier into an unwitting accomplice that helps the worm survive.
So what does this all mean for us? Well, this deep dive isn't just a cool biology lesson, it opens up some incredible possibilities. Think about it. If one infection can prime our body to fight a totally different one through this general alarm system, what does that mean for the future of medicine? Could we actually design vaccines that don't just target one specific virus, but that train our body's defenses to fight entire classes of invaders? That's the really exciting question this research leaves us with.